Welcome to Team Engineering Challenge. My name is Jesse Domer and I am the National Technical Chair for SkillsUSA's TEC Contest. In this video, we are going to learn some more about what is Team Engineering Challenge. In a previous video, if you've already watched it, we talked about how to set up the supplies, whether it's at a district or regional level event, as well as potentially using a supply store for a state and or national level event. In this video though, we're going to back up and talk about what Team Engineering Challenge is, what it looks like, maybe some thoughts on how to plan for running this contest at your level, and some tips and tricks for getting ready. To start with, what is Team Engineering Challenge? TEC is an open-ended problem-solving contest for a team of 3 students to compete in. The open-ended problem follows along some theme related to STEM, or technology and engineering education. In past years, my technical committee and myself brainstormed various solutions for ideas that the students would be competing for. In the national guidelines that you'll find online, they're very generic, talking about what to expect, what to plan for, what supplies to bring, what to wear, those types of things. But they don't go to any detail of what the contest is actually going to be or what the kids are going to build. That part of the contest is what they see when they arrive on the day of in an extra packet that goes into those details. I'm going to talk about some various level types of packets that we've used over the years, whether it's the National 2015 Conference, where they did a trolley car, or the Wisconsin State Conference in 2015, where they built a water boat or river boat type system, or other types of contests. We're going to talk about what those contests or the actual challenge might be and how to set up for that event. A lot of the focus of this conversation is for technical chairs and state directors trying to start up or continue running a TEC contest at your event. However, most of the information or none of the information actually being provided in these videos really gives any insight or highlights or gives any student competitors an edge over others. Anybody can watch this video. It is no different than anything that we tell anybody else, other than we're just providing it in one place or one location. The topic, whether it's building a boat or building a car or building a trolley car or an airplane, what is the topic going to be for your event? Now, if it's a district level event where maybe you've got 20 teams coming in and they only have 2 hours to compete, after school type of an event, whatever it may be, it needs to be fairly simple. It needs to be something students can come in, get briefed, be told what it is, go build and test and be done in 2.5 hours. So you're looking at fairly simple designs, whether you're sorting marbles or building paper bridges or those types of things. Those types of events, those types of competitions are fairly easy to come up with. I like to think of similar to contests or challenges or activities you're already doing in your technology and engineering education classrooms. So egg drops or bridge testing or those types of things can probably be used at a district or regional level event, maybe with some tweaking so that it's a little more advanced than what they've already done in their classroom, but it's similar in time and in ability level. As you move on to that state level event, I like to think of the state level event as typically having at least a full day, if not maybe a day and a half to 2 days of competition. Students can get into building for 4 or 5 hours. You've got plenty of time for judging and testing in that time frame. You can really go all out with those types of contests. So as a technical chair planning for a state event, my encouragement comes a couple of different ways. One, make it hands-on. In my experience of running this contest on and off for almost the past 10 years, is students and teachers and programs really enjoy a hands-on project where they build something and they actually test that device. Yes, there's presentation, yes, there's interview, but there's something that they can actually walk away with and say, I did this. My experience, that comes in way more positively than just a presentation. So at a state level event, hands-on. Another way I like to look at the state level contest theme or topic that you're going to build, I typically talk about it being a typical classroom activity, maybe like a egg drop, but make it on steroids. Make it be that thing that you've always wanted to do in your classroom setting, but you just didn't have enough curriculum time or enough prep time or enough, whatever it might be for the answer. Here at this state level event, this is when you get to go all out with that activity. So whether it's water boats, I'll use for an example. At the Wisconsin 2015 State Conference, we chose to do a water trough with a boat. And many tech ed classes, whether it's middle school or high school, have all done some sort of a boat where you put it in there, you attach a string to it with some weights, and you run it across the water trough, and you got all kinds of engineering data that you can collect from that idea, from flotation to buoyancy to speed and miles per hour to you name it. There's all kinds of great stuff that you can do with that. But a lot of classrooms are already doing that. So how do we take that activity and put it on steroids? Well, we did a couple of things in 2015. One, we wanted to get rid of the string to pull it across. We wanted to make it self-powered. So we gave every team the ability to have batteries and switches and battery clips and wires and propellers for their boat. And they actually made a self-propelled, self-contained vehicle that traveled down the water trough all on its own. Sounds great, but it's just a water trough. We want to have more excitement around that too. So we did. We drilled some holes into our 20-foot water trough we had at each end. At one end, we pumped in a pond pump to it, and at the other end, we pumped in an outlet. And when we turned that pond pump on, it ran water through the water trough and put current into this trough. So now the boats are not only going down it, they're also going against a current. And as the farther they get, the stronger that current got all the way down to the end. So when you talk about a typical classroom activity of doing boats, we turned it into steroids and made something with current and power and electricity within those designs. So it was a lot of fun. It was challenging for the students, and it was something you don't typically see in your classroom because of space for this 20-foot trough being stored somewhere and only used once a year, and the ability it takes to build that thing and use it. It's not something most classrooms have the time to put together. Not saying you haven't, but we went that far with it. So what is the activity you're going to come up with for your state level event, or students might be going and competing at the national level of what would they be going up against? Think about those types of things. How can we make something hands-on, exciting, and challenging at the same time that they're going to walk away with some fun? The topic themes, in my experience, typically follow around somewhere in transportation. Now, we might be talking manufacturing, or we might be talking space, or we might be talking some of those other types of things around the topic itself, but a lot of times we find something moving, something doing something, that transportation idea it is really exciting for students to be able to come up with and do for those types of ideas. So when you come up with your theme or your topic as a technical chair for the year, you might have your supply list, you might have your rubric and your store and your written test and all these different things ready to go. But when we start thinking about that specific topic and what might be needed to accomplish that, there might be extra supplies. For instance, the water trough. We talked a little bit in the video from the supplies that we had to provide some extra supplies that year in the store. So every team actually got automatically a 9-volt battery, a 9-volt battery wire clip, some wires, and a switch. And every team also had the ability to purchase some different propellers, whether it was a water propeller or it was an air propeller. We had some specific items available that year that we felt were needed to accomplish that task. But there wasn't just one solution still, even though we kind of pigeonholed what they had to use. It wasn't just one answer for all 110 teams at that state conference that year. We saw many, many different answers for that project. But whatever the theme is, whether it's a trolley car or a Mars rover or a sail car or whatever that project may be, a marble sorter, you're probably going to need some specific supplies in the store that year to accomplish that task. So you do want to think about what some ideas are students might come up with so that you can pre-plan or be ready for those ideas in competition time. And the students may come up with ways to do it that don't even use the things you thought. I don't know how many years my technical chair and committee and myself have been watching a contest and we're thinking something's going to happen, and kids are doing something completely different. It's awesome to see the creative options that they provide. And that store, using the TEC supply store that we talked about, gives so many creative options for the students to be able to create anything they want. They're not all using the same supplies, even though they have access to the same supplies. So special supplies. That year with the boat was the first year that we ever used electricity with the students. Now, we've had the testing devices use electricity before, and we've done other things like that, but we've always thought that we wanted to keep it to non-electrical stuff for students. However, we tried it last year and it worked very well. But it didn't come with different complications. We did have to provide a little more training and a little more patience with students on basic electrical circuits. You know, if we've got these 6th and 7th grade middle school students competing, or even entry-level freshmen coming into this contest, and they've never wired up a motor in their life or don't know how to wire up a switch or things like that, you've got to work with these students. So we provided some diagrams. We provided some display boards of the electrical circuits hooked up where they could actually turn them on and off and see the wires hooked up to them. And we came around and talked to extra teams as they had those types of questions, and we gave them those answers. Now, there's a lot of answers we don't give to students. If they ask us something, a lot of times we just shrug and walk away. And we tell them that on purpose because a lot of times there's no wrong answer. But on that electrical circuit piece, we made sure to give extra support to those teams because we knew that would be something that not everybody's going to know coming in. That concept is something I want to spend a minute on, and that's the idea of this contest is called Team Engineering Challenge. And so often when we think of engineering, we think of high-level problem-solving, ordered thinking. We think of building advanced construction type devices. We think of knowledge in high school and college and all this stuff, and yet we've got these 6th and 7th and 8th graders, these freshmen are competing well in this contest. So as a technical chair, I urge you to, yes, try to challenge the students, come up with really cool ideas for them to compete in, but remember their ability level. This is not necessarily a contest designed for that senior level capstone engineering team that's taken all of those courses and is going on to MIT or MSOE or whatever that college in your state happens to be. Because we also have to remember we've got those younger students competing here. So even though it's Team Engineering Challenge, I want you to think about it more of a hands-on problem-solving type contest. Yes, we can get advanced. Yes, we can have some cool stuff. But if you come up with a theme as a technical chair that completely is awesome to those seniors, but these 6th and 7th graders have no chance at competing, we've just lost a portion of your competitors. So be aware of that as you go into your ideas and into your contest. We're preparing future technologists, whether it's engineers or machinists or culinary people or whatever that career choice is going to be for the students. Team Engineering Challenge provides a foundation for those students to succeed with. It's providing them a way to build something. It's providing them problem-solving techniques. They're working with a team to come up with a common solution that all three of them can own and use. They're presenting their information in a presentation to a panel of judges. They have an interview portion where the judges are asking them questions. They have a testing phase where their product they build has to work. All of these are skills that every career uses and wants strongly in our future students. However, it is that entry-level type contest for students to get excited about. So Team Engineering Challenge, though it has the word engineering, and yes, we can cover engineering stuff, please remember your audience as a technical chair. I've talked a little bit about Team Engineering Challenge being high school as well. And although Nationals currently is middle school only for those students to compete in Wisconsin, and it's just one basis I know and have knowledge of, we have high school and middle school teams competing in TEC. In fact, out of the 110 teams of 3 students each competing, so over 300 students in Wisconsin 2015 state conference, 80 plus of those teams were high school. 80 plus of those teams are not advancing on to nationals and still are coming back year after year after year for the excitement of what this contest offers and the chance to be on stage as the best against all of those competitors. Yes, we've got 20 plus middle school teams competing, with one moving on to nationals and multiple states coming to that national level for middle school. But as the state technical chair of TEC, I do encourage you to think about opening this contest up to more than just middle school for your students, for your schools, for your state program to be able to grow, excel, and have more opportunities. It is an option for your states to do that. As a technical chair, I've got some more notes that go into how to better plan for your event. And there's a couple of different areas, from testing to time and judging are 3 bullets I'd like to cover in this next portion. Testing. Students are using the supply store. They're building up a boat, let's say, and they want to test this boat. Now, if you're like me in Wisconsin, where we have 110 teams, and you can imagine if all of these teams were trying to test during that first day of build time and just see if things work, that there'd be a huge line at the one trough for students to work on. So we actually have more than one test device pretty commonly at the state level with that many teams. We actually built 3 troughs that year. We had 2 troughs that were 10 foot each, and they were just a water trough, just like you'd probably see in your normal technology education classroom when you're doing boats. So it's just water in a trough sitting there stagnant, and students come up to it anytime they want, set their boat in, turn it on, do whatever they want, and leave. There was no time limit. There was no necessarily line. Yes, there was professionalism, and the teams did very good. But there was 2 of those troughs for them to go up to. Well, let's say they just wanted to see if their boat floated. We also had a bucket of water available for them in another corner of the area. So if they just want to set it into a bucket of water, we've got that option for them too. They don't have to wait for a trough. But we also had the final testing trough with the water flow and everything running all day, both days. And students can come up and test their boats on that actual final testing water trough up to a certain amount of times. So we gave each team 2 times to test automatically. They had a little chip. When they turn in the chip, they get 3 minutes at the water trough. Their 3 minutes are up, the next team goes in line. And they can do that a couple of times. We also allowed for them to purchase those test passes in the supply store. They were pretty expensive, but quite a few teams took advantage of getting a 3rd or 4th test run on the final water trough. So they have those abilities. But on the side of building those devices as a technical chair, you need to think about a number of things. Cost. How can we build this device on a low budget? Because you probably don't have an unlimited budget to build or buy or do all of this stuff for Team Engineering Challenge. You're using scraps, you're using your local Lowe's, Home Depot, or Menards, you're trying to find sponsors, you're doing all this stuff to do as much as you can with the budget or the little money that you have, or maybe it's out of your pocket, who knows. So you need to think about those types of processes as you're building your test device. You need to think about how you're going to transport that test device, and probably the biggest, can it be repetitive? Can 110 teams come through this and test on it every time, and every time it's the same test each time? That's important, so it needs to be rigid and strong and repeatable. So the test device is something as the technical chair you're providing, one or multiple of them. Time. Time is important. Depending on how many teams you have, how many days you have for competition, you have to think about how much time can we give them to build, how long is it going to take to test all these devices, how long is it going to take to judge all of them, to score them. If you have more than one panel, you're going to have to go to round 2 callbacks and plan on that. Just for an example, in the Wisconsin State Conference with 110 teams, if we provided every team 2 minutes at the trough, that's going to take me 200 minutes or almost 4 hours to get through every team to the trough. So just testing on the trough is 4 hours for that many teams if I'm using one testing device. I happen to have about 6 judging panels going that year. So every 2 minutes a new team is coming to the water trough and they're going to judging panel A. And the next team comes up, and when they're done they go to judging panel B and C and all the way down the line, and by the time 6 is done, or judging panel, the 6th one is done, I'm kicking the next team to A. and we just keep cycling those judges through, so it's not an extra amount of time. We're trying to move that along as quick as we possibly can. All in all, 110 teams in Wisconsin takes almost 8 hours to judge. And with that process, it means that they only get 4, 5, 6 hours of building time in their contest. And you need to think about that to the complexity of the project and how much time they need for those things. We talked about the judging portion. For us in Wisconsin, middle school is judged in separate judging panels from the high school. They're graded separately. They have the same rubric. They get first and second, third on stage just like high school does, but they have their own panel of judges judging just middle school versus judging just high school. So it's a little bit more equal playing ground when it comes to that. We typically try not to do callbacks for middle school. If we've only got 24 teams or so, we can do that with one panel of judges. But if you got more than that, we typically need more panels of judges. So high school has callbacks. We'll take the top 3 teams from each high school panel of judges and we'll pull them back, 15 teams or so when we're done, and we'll send them back through. And then the top 5 actually get recognized with trophies and awards on stage. With 80 plus teams, we went to 5th place in 2015 Wisconsin for that process. At the national level, very similar. We can probably get through 20 teams at the national level with one panel of judges with no callbacks, but at some point we really do hope to get to callbacks at the national level with that same process. The teams are going to be testing their device, they're going to be providing a presentation to a panel of judges, and then they're going to have some interview questions when they're done, and those all make up their points, the bulk of their points for the rubric of this contest. I hope this video has provided a little bit more how-to and what is for Team Engineering Challenge as part of SkillsUSA's contest selection. However, if you have any more questions, you're welcome to reach out to my technical committee or to SkillsUSA national staff, and we will be happy to answer your questions. Our biggest hope and desire is more states are getting involved in this wonderful entry-level contest called Team Engineering Challenge. Good luck to all those technical chairs in starting up the event, and to all those student competitors trying to see what this contest is all about. Thank you for your time.